Hello everyone, and thanks for tuning in. In this video I'm going to show you how to prove that the arctan of 1/2 plus arctan 1/3 equals pi over 4, and without a calculator. Okay, if it was a real application you'd probably just use a calculator, but for the IBHL you're going to have to do it without one. So let's hop right into it. Now, in your formula booklet you have this equation I wrote here on the right. Okay, the addition formula for tangents and angle addition formula. And the left I've just restated the problem. So you can use this to figure out this problem. At the end I will show you a more concise form that's a little faster, but it's good to know where it's coming from because you could use this pretty easily on the test and it wouldn't take you so long to solve it. Now, the first thing I want to clarify here is that arctan of 1/2 is an angle. Okay, it's the angle that corresponds to an opposite side of 1, an adjacent side of 2. It's not perfectly to scale. It's whatever this angle is here. You could call it theta, for example. Okay, in this case it's about 26 degrees. Arctan of 1/3, also an angle. That's why you can use tangent of alpha plus beta equals all that jazz on the right. It's just because you're adding two angles together. So that's the important thing to realize. That's the first one. And the other one is, it's probably something you already know, but let me just refresh you here. If you take the tangent of arctan 1/2, I'm just writing atan to save a little space. This is just 1/2. Okay, the tangent effectively undoes the arctangent. And you might be wondering, well, what happens if you take the arctangent of tangent, and it probably wouldn't be 1/2. Generally you take tangent of an angle, so I'm just going to call it theta. That would just be theta, the inside part. Okay, so knowing that, we can substitute these values. I'm going to call arctan 1/2 alpha and arctan 1/3 beta. And now we can just substitute these directly into our addition formula and solve. So, what would tangent of alpha be? And I said alpha was arctan 1/2, so let's see what we would get. Tangent of atan 1/2 Okay, I didn't really need to write that, did I? Because it's written right above there. It's 1/2. So this is our first term. And I'm going to do the numerator first and then the denominator second, just so it's a little bit more neat. Okay, so that's our first value. Tangent of alpha would have to be 1/2. Now, how about tangent of beta? I said beta is this one here. So if you take tangent of arctangent beta, you're just going to get 1/3. Okay, so tan of atan beta, or atan 1/3, is just going to be 1/3. So I'll try not to say this too many times, but you can think of tangent as undoing the arctangent, okay? And you're just left with whatever's inside. So the top, the numerator, is just going to be those two added together, the green and the red, and that would be 1/2 plus 1/3. 1/2 is the same as 3/6, plus 1/3, which is the same as 2/6, so you get 5/6 for the numerator. Okay, now for the denominator, it's just 1 minus tangent alpha times tangent beta. Well, we already found that tangent of alpha, or tangent of arctangent, is 1/2, right? So I can say 1 minus 1/2. So we already found that, and tangent of arctangent 1/3. For the tangent beta, that's just going to get you 1/3. So something quite nice happens here. 1 minus all of that, it's 1 minus 1/6, right? So 6/6 minus 1/6 also equals 5/6. So you end up with something very nice here. Okay, you get 5/6 over 5/6. that just equals 1. So all of this turns out to be 1 when I substitute in arctan 1/2 for alpha and arctan 1/3 for beta. So let's write this whole thing out. So we have tangent of arctan 1/3 plus arctan 1/2. Okay, it doesn't matter what order you write them in. This equals 1. And now we can solve from here. Because going back to the other page, remember I said that arctangent of tangent equals whatever's inside. Okay? So the arctangent undoes the tangent, so to speak. So what you're going to do here is on both sides is take the arctangent. Okay, so atan over here for all of this, and I'll write arctangent of 1 on this side. Okay, so this is really great for 2 reasons. One, the arctangent on the left undoes the tangent, so what you're left with is arctan 1/3 plus arctan 1/2. And that equals arctan of 1. Why were we happy about this? Well, really what that's saying is, you know, what angle has an opposite of 1 and an adjacent of 1? And, you know, you probably know from the unit circle already, 1 and 1, it's got to be a 45, right? So therefore, arctangent of 1 has to be 45 degrees, or our problem is in radians, so of course you put the answer in radians, pi over 4. And with that, you're finished. This is exactly what we wrote before. Okay, that was the problem statement. It said to prove that. So I've thrown in the 45 degrees just to maybe add some clarification for you. But at that point, you're done. Now you're wondering, but is there an identity that you could use to do this? Yes, there is. You know, if you're rushing on a test, you may want to know how to derive it, because I sort of did that secretly without saying I would. But it's quite analogous. So arctangent u plus v is equal to arctan of u plus v over 1 minus vu. It's really pretty similar to this one. Okay, if you can remember that, you know, it's only a very slight difference. You see you have 2 different terms here. It's tempting to write this. Atan u plus v equals this. Okay, that's not true. Don't make that mistake. All right, but it's quite analogous to the one that's already in your test booklet. So, thanks for watching. I hope that was helpful. If you have any questions or you're looking for some tutoring, you're welcome to send me a message or post something in the comments. See you next time.